What about some gravity questions then? So by this we mean looking in the vertical now. So the acceleration is going to be due to gravity. So not if an object's falling or it's being projected upwards, so it's being thrown upwards, the force acting on it is due to gravity. That means the acceleration on the object is going to be 9.8 meters per second squared, because that is the acceleration due to gravity, which is sometimes called g. Okay, so that's normally given to you on the actual exam paper. It'll say take g equals 9.8 meters per second squared unless told otherwise. And obviously, because it's due to gravity, it's going to point towards the Earth, yeah, so downwards as we normally consider it. So let's have a look at an example. So a bouncy ball is dropped off the roof of a 50-meter tall block of flats. Find the time it takes to reach the ground, and the velocity it has the instant before it hits the ground. So there's two parts to this question. Time it takes to reach the ground, which we're going to deal with first, and we'll have a look at the velocity next. So decide which direction is positive. Now, it's not as trivial this time, is it? Here's an illustration of the motion. Here's the top of the building, and here's the ground. Now, as I said right at the start, it doesn't matter whether you choose upwards or downwards as positive. You just have to be consistent in the way you apply it through the question. You'll find it actually makes no difference. All the negative signs will cancel themselves out, but you have to consistently apply the sign convention, otherwise you'll get problems. I'm going to choose downwards as positive because that's the direction the ball's moving in. It's moving downwards, but there's nothing wrong with choosing upwards as positive. It just means you'll get a negative displacement instead of a positive displacement because it's moving downwards, and we'd be taking upwards as positive. But for now, and for the sake of this question, I'm going to take downwards as positive. So now I need to list out my SUVAT. Which bits do we know? Which do we need to work out? Well, we know S is 50 meters, and because we're taking downwards as positive, S is going to be positive too because it's moving downwards. Okay, so S is going to be positive. If we'd taken upwards as positive, S would have to be negative 50 meters because the ball's actually moving downwards. So the signs get a little bit complicated. The initial velocity is 0 meters per second. Now, why is that? Well, I said the ball is dropped off the roof. It's dropped, so that means U equals 0. Okay, if it's dropped, it means I've just let go. It initially had a velocity of 0 meters per second. So look out for those hidden ones in the question where they do tell you U, to tell you what the initial velocity is, but not in so many words. They just say starts from rest or is dropped. Final velocity we don't actually know, and we also, for the first part of the question, for this part of the question, find the time it takes to reach the ground. We don't care what the final velocity is. We only care for the second part of the question. A is going to be 9.8 meters per second squared. Because we've taken downwards as positive, the acceleration due to gravity is also positive because it points downwards. It always points towards the ground. And the time we don't know, but we want to know it for the first part of the question. Now, we don't care what V is, so we're left with the other four, these two and these two. So we're looking for the SUVAT equation with S, U, A, and T. If you look in the formula book, you'll find that's S is UT plus half AT squared. We now need to rearrange that equation for what we want, and we're after T. Now, in this case, before you start rearranging, you might notice this is a quadratic in T, so it's going to be a real pain to rearrange. But U is 0. Now, because U is 0, this entire term is going to disappear and become 0, okay? Because 0 times T is going to be 0. So that means we can simplify it just to S is half of AT squared, and now we can very easily rearrange that to make T the subject. Before, because it was a quadratic, we probably would have needed a quadratic formula, but because U is 0, it makes it a lot easier for us. And now we just solve the equation, substitute in what we know. We know S is 50, we know A is 9.8, and we can find T is 3.19 seconds. Okay, so let's move on to the second part of the question. It said, as well as the time, we want to know the velocity it has the instant before it hits the ground. We've already done the direction bit. We now want to know which bits of SUVAT do we know and which do we want to work out. S is still 50, U is 0, V is what we want to know, A is 9.8, as we discussed before, and it's now T that we don't care about. We do actually know what T is now because we just worked it out, but I've left it blank for now. If we know more than three things, we've actually got a choice of which equation we can use. We just need an equation with which involves the thing we want to find, which is v in this case. But in this case, I'm going to stick to looking at these four. I'm saying we don't care about t because we do know it, but we don't need it in this question. So we now want the SUVAT equation with SU, V, and A in, which we've actually seen already. It's v squared is u squared plus 2as. We now want to rearrange to make v the subject because that's the thing we're looking for. We're looking for that final velocity, the velocity as it hits the ground, or just before it hits the ground. Obviously, when it hits the ground, the velocity will go to 0. But in a SUVAT question, we're not considering the forces that act on it apart from gravity. So we're actually looking for the velocity just before it hits the ground. We now rearrange that to make v the subject. And we now solve the equation. Substitute everything we have. U is 0. We've got 2 times the acceleration times the displacement. You stick that in a calculator, you'll find v is 31.3 meters per second. Okay, so that's the velocity just before it hits the ground down here somewhere. Okay. Now v is positive because we took downwards as positive, and obviously the ball's still traveling downwards at this point. So it makes sense that that's a positive number. If you take an upwards as positive, and it might be worth having a go at this to see if you can understand how all the signs change, you'll end up with minus 31.3 as the answer, because if upwards is positive and the ball's traveling downwards, it's going to have a negative sign. So let's have a look at yet another example. This time an object is projected vertically upwards. So projected just means effectively thrown, or it's launched vertically upwards from the ground at a velocity of 15 meters per second. We want to find the velocity when the object is 5 meters above the ground and find the maximum height the object reaches. So we'll deal with part A first. Decide which direction is positive. Well, let's draw it out. This time the ball's actually going upwards. It starts at the ground down here and it goes up to 5 meters above the ground. Okay, we're looking for the velocity when the object is 5 meters above the ground, so we're taking our end to be when the ball is 5 meters above ground. Okay, or 5 meters above the start. Because the ball's traveling upwards, I'm going to take upwards as positive here, and also because it'll let you see how we treat it differently when we take upwards as positive in a gravity question. Which bits of SUVAT do we know, and which do we need to work out? Well, S was 5 meters. The ball's traveling upwards, and upwards is positive, so S is positive 5 meters. The initial velocity was given to us in the question. It's 15 meters per second. The velocity is the thing we're after. We wanted the velocity when the object is 5 meters above the ground. Now the acceleration is now minus 9.8 meters per second squared, because the acceleration points downwards because it's due to gravity, and gravity always pulls things downwards. And we're taking upwards as positive, so it's actually a negative here. And t we don't care about. We haven't been asked about it, and we don't know it. So now, don't need t. We're left with the other four. You've seen this equation before. We need v squared is u squared plus 2as. We do a bit of rearranging now to make v the subject, and then we just substitute in our variables. That gives us v is 11.3 meters per second. So started at 15 meters per second. Because it's decelerating, it's already reduced to 11.3 meters per second by the time it's 5 meters into the air. Okay. Always good practice to write out SUVAT, write down everything you know, write down the equation you're using. You have to remember as well as being just good practice and helping you get the right answer, you get marks for this as well. If you happen to mess up on a tiny bit of mental maths, or type a wrong number in the calculator, you'll still pick up lots of marks for having correctly got all the parts of SUVAT and correctly choosing the equation. Let's deal with part B now, find the maximum height the object reaches. Well, how do we do that? Well, we do it like this. We say, well, if the object has reached its maximum height, what would the velocity be at the end? Well, the velocity must be 0, mustn't it? If it's reached its maximum height, it must have temporarily stopped at the top of its motion just before it starts coming back downwards again. So to find the maximum height, we can actually say, well, the final velocity is going to be 0 at its maximum height. So that gives us another part of SUVAT that we know. Again, I'm taking upwards as positive here, so be careful with all the signs. Which bits do we know? Which do we need to find out? S is what we're after this time because we're after the height, which is a displacement. We know U. V we've said is 0 meters per second because we're looking for the maximum height, and the maximum height it'll have a velocity of 0. The acceleration is negative because we've taken upwards as positive, and acceleration always points downwards. So that's minus 9.8. And T we don't care about again. Cross out the bottom one, we're left with these 4, so it's going to be the same equation, isn't it? But this time we want to find out S, so we rearrange to make S the subject. So I've pulled U squared across and then divided by 2A, that makes S the subject. And I can now just substitute in the things I know to find the answer. And be really careful with your negatives here. We've got a minus 9.8 on the bottom, which means our displacement ends up being positive. Okay, and that's correct because the ball's traveling upwards. We've taken upwards as positive, so the displacement will be positive, and we find it's 11.5 meters is the maximum height that it reaches. Okay, so we asked in part A, what's the velocity after 5 meters? It was still traveling upwards, if you remember. But at 11.5 meters, it stopped traveling upwards, it's reached its maximum height, and it's just starting to come back down again. It's reached the top of its motion, and it's coming back down.